This video is a special one because in this video it's not just about tools, but we are going to accomplish something. We're going to analyze the terrain of a site for vineyard sites selection. This shows the power of ArcGIS in planning and selecting suitable sites using various data available. These data are readily available, so you can go to the link I'll provide in the description of this video, where you can find the guide to analyzing terrain for vineyard sites in ArcGIS Desktop. So let's begin our lesson today. First, download the data. I might be providing it here, or you can get any elevation data and use that for your analysis purpose. I have downloaded some data and I've opened up my ArcGIS Pro. Now let's create a map, or you can also use start without a template. This time I'm going to start without a template. Now with this blank template, let's go to insert and create a new map. You can just create a simple new map. Then this will quickly spin up a map for you. Let's wait for just a few seconds. This might take some time. And it's ready. Good. For our demonstration purpose, we won't be needing the world topographic map, so let's remove this, and also let's remove the world hillshade. Now with this blank slate, instead we'll be using the USA topo map layer. How can we add that? Well, it's quite easy. You can simply go to catalog, and if you don't see catalog here, then it should be somewhere here, I think, in view, or somewhere. It should be somewhere here as well. You can just open the catalog and then go to portal. Here we'll be leveraging the living atlas feature of ArcGIS. So living atlas provides various features in free they're provided by Esri. So let's search for USA topo map. USA topo map. There we have a web map and also tile layer. Let's add the tile layer. Right click it and add to current map. This will add the USA topo maps. Now here we have the topo map. Then we'll be adding some of data, like let's add our elevation data. So in my case, I have my elevation data stored in my folder. I'll quickly find it and import it. You can also import it easily. I have located my folder and I have located my data. I'm going to just add the SD elevation data. You can also add your elevation data. Just right click and load the data, or you can simply drag and drop it to the map. Once it's added, let's zoom to the layer. Right click and zoom to layer. So that's the elevation data we have. Now we're going to use this elevation data to do something. What's our requirements? Let's understand this. we need elevation above 200 meters. Our suitable area is the one which has elevation over 200 meters and slope between 1.5% and 15% and south facing exposure. So we will be needing elevation, slope and aspect to understand the direction as well. So that's what we are going to do. First, let's get familiar with our data. Here, if you see the elevation data, what do you find? At first, let's adjust the transparency of our elevation. Click the layer and then go to raster layer, and let's change the transparency to about 40%. Now in this way we can see the map and also the elevation. As you can see, the elevation it's nicely aligns with the map, right? Now if we zoom in to the northern area, here we have Montgomery Field Airport. That's what we find here. Now let's understand the layer of elevation. If we look here, there's a BM 414, so that's the elevation of that BM. But in our elevation area, what do we find? Let's click there and see. The value is 127. That's the pixel value. What does this mean? It means that the elevation of provided by the ST elevation layer and by the topo map are different. Actually, the units are different. If we look closely, we can understand that the 414 is actually feet, but 127 it's actually meters. How can we convert meter and feet? If we multiply meters by 3.2808, then we get feet. So it's almost the same, right? 416, 414. So we understand that it's in meter. What about the horizontal unit? For that, right click it and go to properties. Then in I think in source, in source also we can find in spatial reference. If you click spatial reference, then there you see the linear unit. The linear unit is in feet. That's what it's written. So we see that the linear unit is in feet, but vertical it's in meter. Why is that information important for us? Because it has to do something about the tool that we're going to use. While we're here, let's also explore other things like the projection coordinate system and the projection system. Also, what's the cell size? Can you see the cell size? It's in raster information. It's 93.27. So you see it's in feet. That's why you see it in point. So that's the basic information. Now to start our analysis, let's first set up the environments. That's essential. Go to analysis and click environments. Then in environments, workspace, you can change it to the place you want, or I'll let it be where the project is. And output coordinates, let's use it same as, okay, let's say the output coordinate to be ST of the ST elevation. Others should be fine. Then in the processing extent, let's change processing extent to be the same as layer of ST elevation. Okay, click this button and then choose ST elevation, then expand the raster analysis. There we'll select the cell size to be same as layer of ST elevation. That's what we're going to do, and that should be it. Let's click OK. We have configured the environment for our project. Now let's get to our main task. We have completed step 1 and we have explored the data and also changed the analysis settings. Now let's go to step 4, creating a slope surface. How do we do that? Simply go to the geoprocessing. If you don't find it there, then you can always go to analysis and click tools, then the toolbar will appear, and then let's search for slope. Select the spatial analyst tool, the slope which is under the spatial analyst tool, and what will be our input layer? It's going to be ST elevation. Output layer, what do you want to call it? Do you have any ideas that you want to share? How about we call it SD slope? Nice and simple, isn't it? Now, output measurement, we have two options here, degree and percent rise. Which one should we choose? Well, it's based on the requirements we need. If we look into here, then what's our requirement? Slope should be 1.5% and 15%, right? So we need it in percent. That's why let's choose percent rise, then we'll get the output in percent as well, and everything should be fine. But one more thing to keep in mind is the Z factor. So what's the Z factor? If you quickly look to the information, the help icon, then you can see that if both the units are in the same measure, the vertical and horizontal unit are in the measurements are in same units, then the Z factor is 1. Otherwise we'll be multiplying the Z factor to convert unit. As we just saw, the vertical and horizontal unit of our data is not the same. So what should we do? We want to change the vertical unit from meter to feet. So 1 meter is 3.2808 feet. So that's how we convert it. Now I hope you understand that. If you don't, then please leave your queries in the comment. Now let's just run the tool and we get here the slope. That's the slope data. As you can see, different colors represent various slope. The slope which is less than 3 is represented by lighter color, but darker color represents more slope. So that's just for a visual purpose. You can always go to property, go to symbology and change it. Like mostly people prefer stretch, and we can always change the color. So in ArcMap we normally find the default one to be green to red. In our case it should be I am having a hard time finding the right color. Let's choose this one, green to red slope. So that's the default one. So red one means it has very steep slope, but the green one means it's flat, plainly, almost flat. Now what are we going to do? You see the slope is from 0 to 106, but we will be needing the slope from 1%, 1.5% to 15%. And we'll do that very soon. Now next we'll be deriving the aspect surface, because that's what we need. We need the aspect as well. So how do we do that? Simply go to geoprocessing again and back. Let's search for aspect. Search and select the one which is under spatial analyst tool. Input layer is going to be ST elevation, of course, and output layer. Can you guess it? What's the output layer that I want to name? It's going to be ST aspect. Nice and simple. Let's run it without worrying about anything else. This is going to create an aspect layer for us. So this is the aspect raster. Let's explore the aspect layer as well. Let's go to aspect and change the raster layer. Click the raster layer and change the transparency to 40%. Click enter. Let's turn off the other layers. What do you see here? There's something very interesting. In this island, if you look into the island, we can see there is visible banding in the aspect surface, right? The bands are due to the coarse 1 meter vertical resolution of the elevation data that we just obtained. So if we had more finer elevation data, then it would not be so coarse. Also, if you see the aspect, it's ranging from -1, that's flat, so it's essentially from 0 to 360. So that's the degrees, the angle of aspect. The one facing north is from 0 to 22.5 degrees. That's how it's classified. Now we have all the data that we need to perform our analysis: the elevation data, slope data, and aspect. Now we'll put all this in one place and perform some analysis which is called binary suitability analysis. How do we do that? How do we perform a binary suitability analysis? Let me show you how to do that. Simply go to geoprocessing or your tools and then search for raster calculator and click the one which is under spatial analyst tools. Now just keep in mind our requirements and we are going to write an expression together. It's very easy actually. Since we're going to have multiple criteria, let's use parentheses to wrap our expressions. So first use the parentheses, open the parentheses, and then add elevation. Let's work with elevation. So what should our elevation be? Double click the layer and then it will appear here. What's the requirement for elevation? It should be above 200 meters. So elevation is greater than 200 and close it. You can find these operators in here as well, so you can use this as well. Next, what do we need? Slope should be between 1.5% and 15%. But how do we add that expression here? We have created just one expression. We can add that by using ampersand, this sign, this ampersand sign. So you can find it in your keyboard or you can always add it from here as well. So we have the AND operator. Then let's use another parenthesis. What's our other requirement? Let's see the guide. Slope should be between 1.5% and 15%. So let's change it. Let's change the slope. Slope is in SD slope raster. So double click the SD slope. It should be greater than or equals to 1.5, right? And close it. Then let's write another ampersand sign, and again the SD slope should be less than or equals to 15%. I hope I got the expression right. 1.5 to 15%. Yes. So we're doing good so far. Now, what's other requirement? Let's write another ampersand and use another parenthesis. Our aspect, it should be, what should be the aspect? Our requirement is that it should be south facing, the southern aspect. So what do you see in the legend, in the layer area? Which aspects are south facing aspect? Southeast, south, and southwest, right? So it starts from 112.5 degrees. So ST aspect is greater than or equals to 112.5. If just in case you're wondering, do I need to put space between these operators or not? Well, it's actually optional. You can put space between these operators as well, but don't put space between the greater than and equals to symbol, please. Okay, so aspect should be greater than or equals to 112.5. Good. And let's chain it with another ampersand, and again the aspect should be less than or equals to what's the maximum value for south? 247.5. 247.5. So that's how we have created an expression. Congratulations on creating your first expression, if it's your first expression of using a raster calculator. So let's review. The elevation should be greater than 200, and slope should be greater than 1.5, and slope should be less than 15. Then also what do we find here? The aspect should be greater than 112.5 degrees and less than or equals to 247.5 degrees. So that's how we can create an expression. But in case this is very hard for you, here is an sample expression. You have to change the names. I have just renamed it so that it can be used for any purpose. You can always change it. Also, I've used here some sample angles, but you can always change it as well. Okay, good. Now, what should be the name of the raster? Okay, that's the hard part, isn't it? We should call it something like ST potential sites. So this is going to be the potential site for our what happened? Is it too long? The length of grid base name, oh okay, it's too long. Let's not call it that. Yeah, okay, ST potential, let's just call that. And let's run it. It was quick, wasn't it? Right click it and zoom to layer. What do you see? Gray value, you see just two values, right? Gray and red, 0 and 1. Gray value, it represents that these are not suitable area, and red, it's suitable area. Let's change the gray value to be transparent instead. Let's change it to no color. Okay, and let me turn the other layers off. So that's our suitable area. That's where we can plant our vineyard. So next time you visit US, you know where to plant your vineyard, where all the criteria are appropriate. You can also say that in the Coles Mountain, the southern part of Coles Mountain, that's suitable for vineyard, isn't it? So we have successfully performed a binary suitability analysis as well. And overall we have performed performed a suitability analysis for vineyard site selection. We have quantified a terrain surface as well. It was a really informative and practical lesson. If you found it useful, don't forget to subscribe and like. I'll be posting more of these videos. I'll see you next time.